We have seen that light wave communication systems can be classified into guided and unguided light wave communication systems. Guided communication systems are fiber optic communication systems which uses optical fibers for communication, whereas unguided light wave communication systems mean free space optics. We will concentrate on fiber optic communication system and its classifications. So the fiber optic communication systems can be classified into point-to-point links, distribution networks, and local area networks. We will see point-to-point links first. Point-to-point links is the simplest form of fiber optic communication systems. Their main role is to transport information in the form of a digital bit stream from one place to another with high accuracy. The length of the link can vary from less than a kilometer to thousands of kilometers depending on the application required. For example, optical data links are used to connect computers and terminals within the same building or between two buildings with a relatively short transmission distance of approximately less than 10 kilometers. They are mainly used due to their immunity to electromagnetic interference rather than their low loss and wide bandwidth, which again form a property or an advantage of an optical fiber. Undersea light wave systems, they have link lengths of several thousands of kilometers and are used for high speed transmission across different continents. Undersea light wave systems should have large bandwidth and low losses, and in order to reduce the operating cost, the low losses are mandatory. The figure shows point-to-point links with a periodic loss compensation with the help of regenerators and optical amplifiers. A regenerator comprises of a receiver followed by a transmitter. Compensation is required when the link length exceeds a certain value and losses aggregate, depending on the operating wavelength, to prevent the signal from becoming too weak to be detected reliably. Regenerators are required to regenerate the signal, that is, receive the signal, amplify the signal, and transmit the signal again. So, on the other hand, we have erbium doped fiber amplifiers which can amplify light without conversion to electrical domain. But there are amplifiers which operate on electrical domain. Distribution networks not only transmit information but also distribute information to a group of subscribers. Examples of local loop distribution include telephone services where distribution is a local loop, that is distributed to a group of subscribers, and the broadcast of multiple video channels over cable television. Such networks have the ability to distribute a wide range of services such as telephone, fast mail, data, and video broadcasts. The transmission distance, although they are relatively short of the order of 50 kilometers or less, bit rates can be as high as 10 gigabits per second for a broadband ISDN. In the diagram, we can see the hub topology of a distribution networks. A hub can connect to another hub or a group of hubs, and each hub distributes information to other hubs or other terminals. In a bus topology distribution network, Several terminals or hubs share a common bus. It is through the common bus that the data for each terminal will be transmitted. For hub topology, channel distribution takes place at central locations where an automated cross-connect facility switches channels in the electrical domain. Such networks are called metropolitan area networks, as hubs are typically located in major cities. The role of optical fiber is similar to the role of point-to-point links. Several offices can share a single fiber headed for the main hub, as the fiber bandwidth is very large than that required for a single hub office. However, a concern for hub topology is related to its reliability. Outage of a single fiber can affect the service to a large portion of the network. Means that an outage of a single fiber will affect communication of several offices or to several offices. However, additional point-to-point links can be used to guard against such a possibility of outage by connecting important hub locations directly. For bus topology, a single fiber cable carries multi-channel optical signal throughout the area of service. Distribution is done by using optical taps, which divert a small fraction of the optical power to each subscriber, and several subscribers share the same bus. An example of a bus topology is a common antenna television which uses bus topology. The CATV consists of distributing multiple video channels within a city. The use of optical fiber permits distribution of a large number of channels because of its large bandwidth as compared to coaxial cables. For high definition television, again, large bandwidth of the order of 100 megabits per second or higher is required of each video channel. So compression techniques will reduce the bandwidth requirements as well. Local area networks or LANs refers to networks in which a large number of users within a local area are interconnected in such a way that any user can access the network randomly to transmit data to any other user. Optical access networks used in the local subscriber loop also fall in this category. For such networks, the transmission distances will be relatively short, of the order of less than 10 kilometers, and losses are not a big concern because the distances are short. So the system architecture plays an important role for local area networks, since the establishment of a predefined protocol rules is necessary in such an environment. Typical topologies used for local area networks include bus, ring, and star configurations. As you can see, there is a ring configuration where nodes are connected to several terminals. And in the case of a star topology, a star coupler distributes information to various nodes, as you can see in the figure. So a bus topology structure is similar to one used in distribution network. Example, the one provided by Ethernet, where a network protocol used to connect multiple computers and used by the internet. So a bus topology, there will be a common bus which will be shared by different nodes. In the case of ring topology, consecutive nodes are interconnected by point-to-point links in the form of a closed ring, as shown in the first figure. Each node can transmit and receive data by using a transmitter receiver pair, which also acts as a repeater. A token known as the predefined bit sequence is passed around the ring. Each node monitors a bit stream to listen for its own address and to receive data. It can also transmit by appending the data to an empty token. In the case of a star topology, all nodes are connected through point-to-point links to a central node called a hub or a star coupler. Such local area networks are further subclassified as active star or passive star networks depending on whether the central node is an active or a passive device. In an active star configuration, all incoming optical signals are converted to electrical domain through optical receivers before being distributed to individual nodes. Switching operations can also be performed at the central node since distribution takes place in the electrical domain. In the passive star configuration, distribution takes place in the optical domain through devices such as directional couplers. The power transmitted to each node depends on the number of users since the input from one node is distributed to many output nodes. As in the case of a bus topology, the number of users supported by passive star local area networks is also limited due to the distribution losses. You will learn more about different topologies in some other paper. Anyway, thank you for your patient listening.